Alrighty, welcome back. It's Tuesday. This time I have good internet back, so hopefully this is going to work out. Famous last words. So we have a few things. Now let me open up the invite again so that I'm not subject to things have shifted in my since I sent out the invite. Pretty sure one click was eaten. So yep, okay. All right, so then I guess let's start with this one here.
I can do this. Can you hear me okay?
Yep, perfectly fine.
All right. So, list of T is our collection workhorse. Span of T is our new best friend, but they don't get along very well. There's no way today to add a span as a range to a list of T. You can iterate through the span and add each item, but that's not nearly as efficient as just a copy from one to the other like you get with other collections that you can pass to AddRange. So the goal here is to be able to add AddRange span. The problem is we can't, and I think if it was just that, this would be a pretty short conversation, or I hope it would be a slam dunk. We just add AddRange span. The problem is if we were to do that and we just add that one API, existing use of AddRange passing in an array will get ambiguity errors because an array is both an enumerable and implicitly convertible to a span. And that's a pretty big source breaking change to take. So I don't think we can do that. So we have a few options. One option is we use a different name. Like right here I've written add span range or something. That's one option. Another option is we can add enough overloads of AddRange that this hopefully isn't a big deal. So we can add one for array, which would cover probably the 80% case. There is another case that I believe would also be affected, and that is a string. If you had a list of char, which hopefully isn't that common, but if you were to add range string, I believe that would also fail because string also is implicitly convertible to a read-only span of char and an enumerable of char. And we can't just add a string overload, and nor would we probably want to, since that would only work for a list of char, not in general for a list of T. So we need to figure out how we want to do it, but I think we should do it.
So how common do people want to treat spans as collections? Isn't that super rare? Because most of the time you're dealing either with chars or with bytes. Like list of byte doesn't strike me as something that people actually use.
List of byte, probably not, but list of person where you've sliced some other collection and you're adding that slice. Right. If I have an array and I slice down to a portion of it and then I want to add that to my list, that's pretty reasonable.
Yeah, there's all kinds of places where I've got lists of things like vectors, like not vector 128s, but rather vector 2, 3, and 4, like you use with meshes and graphics rendering. And where I've got the list because I need a long-lived growable allocation. But where for other operations I might be getting the backing. I might be using collections marshal to get the underlying span to a list, or I might be creating temporary stack allocated lists for perf reasons, and having to convert it to an array or write my own for loop that adds each item is not fun.
So I had opened a similar issue for copy2 a couple years ago that effectively got closed because we have collection marshal as span for list. Is there something
that doesn't solve this problem? So the copy2 that's part of this I added just because at the very end of the issue, Eric asked me whether we could add that in, so I copied it in. But you can't solve AddRange with collection marshal that has span.
Yeah, well, for solving it via collections marshal, we need the other API that's been proposed, and I don't think is marked for ready for review yet, which is we'd need to be able to explicitly set the count of list unsafely. That way you could set a capacity, you could force grow the count and then get the underlying span and set the items manually.
Right, it's just the count that's the problem. You can set the capacity today. You could copy it into that unsafely. It's just updating the count is the problem.
Right.
That, and it's incredibly, having to use an unsafe method to update the count and then an unsafe method to get access to the span and then copy into the relevant region of that span is a very convoluted scheme that hopefully we don't want to push people towards.
Yeah, it'd be nice if we had it for like an escape hatch so that people could provide their own extension methods that provide this kind of functionality. But I think this kind of functionality is also pretty core to a list type. And I think we should just have it built in.
Yeah, given that we treat span as a first-class high-performance API, I agree that it seems for things that we consider workhorses like list of T, it is too much of a, roll your own for something that we consider core, right? I have to say I don't like the idea of a new overload group, but at the same time, I think I hate the idea of us having to add tiebreakers for existing types that happen to be convertible to IEnumable and happen to have an implicit conversion to span a lot more, because it seems very fragile. It seems like it's kind of like, oh my god, if we add another core collection type that does both, then it's inviting trouble.
Is that a case
and
where?
Also, I'm sorry.
I was just going to ask: is this one of the cases where we should talk with Jared about whether the language can provide something? I know he's previously proposed the binary compat only attribute, but this is a very similar scenario where even for param span, they've had the discussion of, well, span's obviously the preferred choice, but array's the existing choice. So maybe the language should have a built-in rule for saying span is better moving forward. Maybe we should just have a general purpose mechanism of saying, for the purposes of like array, IEnumerable, and span, there's an attribute we can put on to say prefer the span one. That way we don't have the tie-breaking issues with those three.
I mean, we can have the conversation. I think it's going to be very tricky though, right? Because you're effectively saying that somehow we would say arrays would convert better to, IEnumerable or better to span, depending on how you want to run this. And
right, I think we just say span is the preferred overload, or they're an attribute that says, prefer this overload of the two.
Right. I mean, it would be interesting to see what that would look like, right? I think if it's something that is baked into the language, that would be probably unfortunate, like as in if the special case arrays. If it's some sort of generalized feature where anybody who happens to be implementing IEnumerable and also happens to have an implicit conversion to span, could do the same thing that we do for arrays, I think that might be probably better. But yeah, it would be interesting to see what Jared would say. I think there's going to be a lot of pushback on doing that, would be my guess. But because I think what Jared had in mind is more like because it's modeled as an API, you model it as a breaking change, and it's basically a class library level breaking change, not a language level breaking change. But yeah, I mean, the problem is arrays are pretty widely used, right? So are we sure we don't break anything else?
Yeah, I mean, we're daydreaming language features right now, but an attribute that you can put on only one method in a method group that says I win ties. That way we could put things that have overloads of I dictionary and I read only dictionary, and we'd say whatever, I read only dictionary, it wins ties.
Right.
And you have span and enumerable, be like span wins the tie. And because once it's compiled, it's not a problem. The runtime has no issue with it. It's only the language when it ends up with multiple candidates of best. And so there's a new rule for best of the one marked the best wins.
So I do want to draw attention to something that I put in chat, which is remember the implicit conversion to span.
So what was that?
You cut out at the end,
Yeah.
Levi.
Implicit conversion to span of T could throw an exception at runtime. So just be careful.
Win?
Array variance.
Right, but that's a specific case where that wouldn't be an issue, because arrays. So in these scenarios, we always have two overloads: one that takes T array and one that takes span. The issue is when you have span and T array and IEnumerable. There are some APIs that implement IEnumerable and have an implicit conversion to span. And so it's
Yes.
the IEnumerable and span that becomes the issue.
The span?
Yes, exactly. If you have an array overload, that'll just win. Yeah.
But this API also would take a read-only span, which does not have covariant
Correct.
throwing in the constructor.
It's more copy to is really where you have to worry about that, not add range.
Yeah, we can separate the discussion of copy to. This proposal
Yeah.
was initially just add range, and I only added copy to on request. I'm happy to strike it from the API
No,
review.
I
if that
love
makes
it.
this
I love it.
discussion easier. Okay.
Notably, if we aren't dropping copy to from this proposal, other places we've exposed copy to have try copy to.
I mean, Eric pointed out that we already discussed copy to, and apparently rejected it. So maybe it would make sense to remove it from this proposal and then revisit that one if we want something grander.
Mm-hmm.
Yeah, I would also say copy to, like the case where it throws, it would throw today as well, right? Because if you take copy to with an array and you use an array that is using a subtype, that would also throw basically at runtime when copy to actually runs, right? Because
No, it would succeed.
How would that succeed? Because you're passing in a more derived one, and then in copy to it tries to write to an array that needs a more derived one at runtime.
If the particular element you happen to be writing fulfills the contract, it'll write just fine. So a list of object can be copied to a string array that has been downcast to an object array, as long as every element within the list is itself a string. All of those are checked at runtime.
Okay, you are saying there are cases where it might succeed. I'm saying there's also cases where it wouldn't, right? Because it completely depends on what you have. Basically, so you have code that could compile and could throw at runtime. So in that sense, I think that's...
The answer is it depends, yes.
I think I'm more okay with it. But yeah, I mean, it seems like we should have the conversation with Jared to see how they feel about that before we add a new overload group. But I think if you feel strongly about having that support, I have a hard time believing that we would prefer tiebreakers over a new name. The only problem with the new name, of course, is that it's not discoverable, right? If somebody is aware of the existing patterns, they try AddRange, oh, I can't plot in a span, they just give up, right? And then they do whatever they want to do to support the span, probably. They're probably not discovering the add span or AddRange span. They might, I mean, but it's always a problem. Anything else you want to add to this?
So, are we actually going to try to design like the betterness attribute? It seems like kind of cool as a library developer, but like, is that really happening? And if so, like, would we expect that to happen?
I think at this point we're at like the bestest betterness.
Well, I mean, it's not so much that we want to design it, right? Jared had a proposal specifically talking about how a custom attribute could be used to effectively tell the compiler, yeah, in the last version, you like according to the current rules, you would pick this overload, but they want you to pick this other one over here, right? And he kind of dubbed this as binary compatibility, as in existing code behaves the way it does, but if you recompile existing code, we might pick a different overload, and that's fine. So it's not like something that we just cooked up here. There's some prior art here.
Right, and specifically we reviewed that issue and we marked it as, this seems really cool, but we'd want to better understand where we'd use it in the BCL. And cases like this, I think, are very central to the scenario of, we'd like to add this new API, but because of binary compat, we can't without it being potentially breaking change. I think the main difference from the binary compat only is we don't want to mark the other API as inaccessible. We want to mark the we want it to still be accessible when it's an exact match. We just want ties to go towards a better version instead.
Yeah, it's basically for a certain combination of types and conversions, right? I think his proposal basically said like this method here, basically pretend it doesn't exist. It exists only for binary compatibility, which I don't think we want to do for the thing that takes IEnumerable, right? Because clearly there are cases where you still want to use the IEnumerable one.
Because params array to param span, you can say, well, the implementation is just going to be the array one is going to call the span one. So pretend this one didn't exist and move lower. In the case of enumerable and span, there are really two legitimate options, and we're just going to tell you if they're both available, we think one of them is like this one is the better one. I thought we were cutting copy 2. No, you're hitting not approved.
My understanding of the reason copy 2 got rejected was because list of T is super common, and the generic explosion thing that it's like every time you have a list of struct, you're going to get these methods whether you use them or not. So like if we run this by Jan at least to get his
unused generic methods don't get compiled. Like list of T won't go and magically compile copy 2 whenever it's instantiated. It's only if copy 2 is actually used. But beyond that,
right, the concern would be if you did list of string.copy2 in one place in your application, and then you have list of int, list of double, list of decimal, etc., none of which use copy2. The trimmer's still going to keep copy2 around because it's necessary, and native AOT is going to still generate the code for copy2 for all those constructions, is my understanding.
Right, which is really a native AOT problem that they really need to fix.
Well, that might be true, but at the same time, I
just
think
know in general, it's been hard to put things on list. Like I've seen Jan push back multiple times. So I'm just calling it out as a risk here that we would go through the effort of doing this and then reject it in the end anyway for that reason.
That actually raises an interesting possible solution in my mind. Maybe two birds with one stone, although a little bit odd. If we made the span-based quote overloads actually extension methods, they would both automatically lose the tie and not count towards generic instantiation costs.
Oh, that's brilliant.
If we did what now?
If we made them extension methods.
Oh, so like we do for vector, where we've got vector 256 of t and vector dot.
And it would be in core, so we could get access to the internal stuff that we need.
Right.
Yeah. Implementation-wise, you would probably end up adding an internal method to do all of this on list of t, which brings us right back to the same problem.
Maybe. You wouldn't have to. It would be dialable.
It's internal, right? So the internal method could be called whatever you want, and you don't have to deal with overload issues.
Well, it would still get compiled.
It depends. I mean, you could put it somewhere else if you really cared, or you could put it on the class if you wanted to.
Yeah. I'm just thinking that this would cause us to take a bunch of fields which are currently right now private in list of t and start making them internal, so that we could start accessing them from extension method classes.
If we cared about the generic instantiation costs. From my
Don't we
perspective,
already do that for collections, Marshall?
we do.
This seems like like Tanner said, we should just fix it in the tooling.
I mean, I'm just pointing out that from my perspective, this particular method is important enough that even if we couldn't solve generic instantiation costs, it's worthwhile adding it.
Yes. But if we add it, we
Yes.
should just add it in the place where people expect to see it, honestly. Like, it's weird that we would contort the API surface just to work around a tooling issue.
Well,
I don't
Like,
dis-
we have the ability to fix the tools.
for the X of T and X split, that is a very common split we have across the BCL. It's not really contorting the APIs at this point. We do that for span, we do that for vector types, we do that whenever we have overload, whenever we have methods that only apply to a subset of types, etc. So I don't think having list and list of T would be too far-fetched here.
Doesn't have to. We have a collections extensions type in CoreLib that's already public where we add various things to it. We could just put this there if we wanted to.
And for what it's worth, you can increase the capacity externally, and the size field is already internal. So, turns out something in CoreLib can do this without changing the list type at all.
I vote for the extension method right now. Like, I don't want perfect to be the enemy of like good enough, but I also understand that like span APIs are kind of niche to begin with, so maybe we could wait.
Yeah, it's not that perfect is the enemy of good. It's just like, how do people realize that this is there if we start spreading these across multiple different types?
No, but if it's called AddRange, which is the desired name, and it's just collection extensions, AddRange, which extends not iList of T, but list of T, then it could do all of the work and not introduce a compile break, and so it might actually be an elegant solution to the problem.
I mean, I think the user experience would be virtually identical. I mean, in IntelliSense, it will show up. It just shows a different icon, right? Because it's already in the same namespace, right? It's already in the using for most people.
You're assuming IntelliSense?
What do you mean?
You're assuming that people aren't just doing this in like a dummy text editor, that they have a full IDE?
Well, I mean,
I don't think we should design APIs with. I don't think we should design APIs under the assumption someone's coding in 1980 with Vim and Notepad and no IntelliSense at all. That's not a realistic scenario for .NET given its size.
I think I did that all last
even
week.
if they are, all of the vast majority of our span-related APIs are extension methods.
Right.
And they match existing APIs, right? So like someone without an IDE might just assume this already works.
Exactly.
So it's nice to make it work as soon as possible.
I would say, like, given that it's using existing name, it uses existing patterns, and it happens to be an extension method, I honestly think it's for most people unobservable, and it would just work fine, right?
And our docs pages show extension methods on the type that they extend.
So I think the extension method would be fine. I think to me the question is still, it will probably be worthwhile having the conversation with Jared just because it's a real world example of something where the feature might be useful. But I also think I wouldn't necessarily block on the existence of it. I would be fine with saying, let's put it as an extension method, but at the same time, there might be other cases where extension methods wouldn't be the correct solution. We really would like to use the language version or the language feature for that. So I think it's still worthwhile like having the conversation as an example. And I think the API here is not important enough to say, oh, we absolutely should do it now and not block on the language feature. I think it's fine to say, okay, let's table this for now. Let's use it as a poster child for the language feature. And if that doesn't work, then we can do the extension method thing to just make progress.
I was going to say something very similar, which is let's add it as an extension method, simultaneously, like approve it as an extension method, simultaneously have a conversation with the language folks. And if we can change it prior to shipping .NET 8, let's do so. And if we can't, we should continue to ship it the way we added it.
I think that's
Can we
also
add the copy
fine.
to back in then? Because in the end, I actually do want copy to. That's why I logged it in the first place.
Yeah, why would it be split out?
Why would copy 2 be split out into a separate proposal or split out to collections extensions?
As a separate proposal. Like it seems like if we have a pattern we're satisfied with, just bring all 3 methods in.
Well,
Yeah.
I mean, it doesn't match the title at all.
Well, yeah, but
Sure,
that's not
but-
really a problem.
Yeah, we violate that all over the place.
I think we want 4 methods because everywhere we've exposed copy 2, we've also exposed try copy 2. But I think copy2 is pretty standard. It's kind of ridiculous that we have this on like the numerics types, matrix 4x4, plane, quaternion, vector, and the intrinsic vector types, and we don't have it on our standard vector type, which is list.
So when we first approved this, the copy2, we only had copy2. There's no try copy2. It would throw if the thing wasn't long enough.
And while collection.copy2 generally seems to be void, span, okay, and technically span copy2 is void. It really should be int returning.
It's the same. Like there's no reason to return it, because either it didn't write anything and it threw,
or it wrote count and you have to now go read a second property. So use the free, like the A register is burned by calling by invoking a function. Just use it.
Yeah, but I don't think we're doing that in all the places. Most of the places where the count is known or trivially retrieved, we've not returned it.
I mean,
also notably
I can tell you the guidelines because I wrote them, which is return the answer unless it's a fixed value.
And notably also that register is burned unless inlining or a bunch of other things happens, in which case now the JIT has to do more work to decide, can I actually not return this?
Yeah, is what I'll be of T. Yeah, I mean the guideline for span writing things is, I mean, technically, I think we wrote it as the foofy thing of the count should be determinable, but basically it's if you are writing an int 32 and int 32 is in the name, then you're allowed to understand that that's 4 bytes. But otherwise, you should be producing the answer for composition reasons. But if you guys like void, whatever.
There's a lot of places where we've not followed that, where the count is trivially retrieved.
Most of them were done before we came up with the guidelines, though. Like, the guidelines were saying we did it wrong when we did it originally. Which is the only way we learn, is we try things and then decide what we like.
Right. But I mean, one thing I would say is, like, thinking of, like, even if we get the language feature, would we really do this? Because it would basically mean we would most likely break VB or F# unless they add the exact same language feature to it. For core types like list of string with AddRange enumerable of char.
So F# doesn't have most types of implicit conversions. It's going to minimally add a few of them, but it's still going to be extremely limited in how it does that.
Right, but it would support them for arrays and strings. I think they added that support for it, which basically would be the reason why it would break in the common case, right?
Well, so we have AddRange that takes a T array already, so it won't conflict. It would only be conflicting if you had a type that was implicitly convertible to IEnumerable of T and read-only span of T.
So we have an AddRange on list of T that takes an array?
A T, yeah, but that takes a T array. Pretty sure.
I don't think we do.
I don't believe so.
The only one I see is IEnumerable.
I see. Well, then we should probably have that one as well. That way it's not an issue.
Well, that was basically the thing that Steven said initially, right? We could add the tiebreakers, but then that seems like a worse fix all up, because I feel like that's fragile, because every time they would have a conversion to both IEnumerable and span would still not work.
Right, but hasn't our premise been that everywhere we expose span, we also expose the T array overloads so that other languages that don't support span works?
Well, yes.
But it's not just our. I mean, it's anyone can have such conversions. So, and we can't add anyone's types. As noted, like, while it's probably pretty rare, we also have one that we can't add, which is string.
Right, but you couldn't. So the only time you could add where string would be conflicting is if you had a list of char where you were doing AddRange string.
Right, which people do, right? So I mean, I'm not sure how common it is, but I've definitely seen people doing that. I think it just comes down to like how much of a breaking change is this going to be, right? And I'm just inclined to believe that even if we had it working in C#, would we be willing to gamble with F# and VB without major gymnastics? And the answer might be in some cases, but I feel like for things like list of T or dictionary, like I don't think we would mess with things like that. Not for highly used APIs like AddRange. So it might be that even if we had the language feature, we would still go down the extension path, basically, is what I'm saying. So maybe that's just a...
Yeah, I mean, VB and F# needing to also take this change or be broken means, yeah, I think that even if we got a language feature for C#, we wouldn't change the implementation this release. If we're going to add it, the way we have it now is the only way we would add it. Or a new method group. Otherwise, yeah, string is a problem for a list of char.
All right, so then are we okay with approving effectively this API shape here? I think that I just looked it up. The other extension methods that take an iList, we just named list, so that would be consistent. I believe the shape here is correct.
Make the method static and it looks good to me.
Oh yeah, that would be good probably.
We've invented the ability to add instance methods to static classes.
One day.
The only question.
One more conversation for Jared.
Except that the whole purpose of static classes was to catch the places where Grunk didn't write static on members of non-instantiable types.
There's that too.
Did we resolve the try copy to question? Is that?
I think we kind of did, right? I think the primary reason why we didn't approve it last time was that it had a workaround with memory marshal. It did feel super fringe, and I don't think there was enough belief that it's worthwhile doing that. But given that we do the other two methods, I think.
Well, that's the copy to question.
Yeah.
Steve asked the try copy to question.
Oh,
so
sorry.
Should we also add try copy to?
Do we have a try copy to on list of T already? We don't, right?
What would a try copy to do? Start copying, and if it didn't get enough, it just stopped and didn't.
I mean, check the count ahead of time and return false.
Yeah, I do the length check instead of you doing it.
I mean, given that it's such a trivial check for the caller to do, I have to say I don't see a huge reason for it.
I mean, we've added it. I think everywhere else we've exposed copy to.
Really?
For span.
Copy to is span, yeah.
Yeah, with span, not for array.
Okay, if there's plenty of other places where we do that, then the argument wouldn't be it helps you a lot. It's just more for conformance and consistency with other code that you already written.
We did it with, off the top of my head, I know we did it with string and memory extensions. Where else did we do it?
All the vector types, all the numeric types. Now that with generic math, all the iNumber types that have the, copy these bytes out, big Indian style and little Indian style have the try copies as well.
I mean, the only places I see it are value string builder, which is not public, and then, the vectors and string, and span and memory directly. So if we have any other copy twos that write to a span, they're not following an automatic add a try.
Well, the generic math ones have a slightly different name because they've got little Indian and big Indian in the name.
As a suffix?
I think so. Let me.
I mean, that wouldn't.
I guess those ones are try write, not copy to.
Gotcha.
Those are write and try write.
I mean, I'm cool with omitting it and then say if somebody sees value in it, we can add it, but I'm also cool with adding it. I mean, as an extension method, I don't see a huge problem with it because it seems fairly pay-for-play friendly. Does anybody have strong opinions?
Less is more.
Then let's omit it.
The last question I have is kind of like shedding on the parameter names. Like, do we need like a source and destination kind of thing here? Because like copy to, list, span.
No, because we don't really expect people to call it an static syntax, right? And so if they do with an extension method syntax, then it's the same as if any other copy to, which doesn't have the naming either, right? It just says span, right?
It's sometimes called destination.
Yeah, calling it destination seems like right now it's called array on list of T and maybe in the collection interface, but that's just because we hadn't come up with the word destination yet.
I mean,
Yeah, like read-only memory to span like is destination, for instance.
Yeah, so probably add range of list and source, insert range, list, index, and source, and copy to list and destination.
All right, then I guess I'm cool with that. And then for add range and insert range, we keep them as span supposedly, or do we go with source?
I don't see why we wouldn't call it source.
Works for me. We cool then?
Ship it.
On it.
2-line proposal only took 45 minutes.
But we got so many neat language features out of it, maybe.
Exactly.
And it warmed us up for how many millions of methods are coming with AVX 512 next.
And,
AVX 512 is one we can skip. It's going to have a dedicated review session with the rest of the AVX APIs.
Good, thank you. All right, ReverseEndianness.
Okay. So we currently expose reverse endian methods on binary primitives for most of the core primitive types, short, long, int, etc. But we don't do it for spans of those. So if you want to, reverse a whole set of them, you have to do the iteration yourself. The proposal here is to, sorry, I'm walking up a hill, I'm a lot of breath, to add support for operating over spans. And there's a question for, and we're going to start seeing this more frequently. In fact, we saw it last week, and I forgot to mention it when we were talking about string.replace, which is what pattern we want to start using when we're doing things that can be done in place, but could also be done with a source and a destination span. So, we could do reverse endianness in place, but we could also do it copying from a read-only source into a destination span. We just need to figure out what pattern we want to employ.
So I get wanting to support both, but in place has to be the primary usage of this, right?
Yeah, I mean, the argument is if you care about in place, you can achieve it with these overloads as long as you allow for them to be the same, reference and length, or at least starting reference. you can't do the other way around, but doing it, if we, it would be simpler if we just exposed the in-place one. So it's a question of what we want to do.
Because you
Or
could
both,
do
right?
the one that, if we only had in place, it would basically be you have to copy it to your destination and then modify the destination in place, which for small spans is equivalent, and for large spans is a cache buster.
Right. I'm also looking at like the sort and reverse APIs that we have elsewhere, and those are all in place. I don't recall any of them taking a source and a destination. So there's definitely precedent for that. That said, like it's nothing. It's no real burden on the caller to just pass the same argument for both parameters. And now, like Steve said, you support everything.
Yeah. Well, there's the question of, is this important enough that it would check for a non-perfect overlap? Or would it just be like, whatever, you call it with an offset by 1 and you'll get what you get?
I mean, it needs to fail or succeed in that case.
So you're talking for like SIMD operations, if they're like a byte offset off, like they could end up like clobbering its own operation or something?
Not a byte offset, but because I can't imagine we care if these things are misaligned with respect to the source and the destination. But like if the destination is one element beyond the source. Anyway, sorry, Tanner.
I was just going to say, so with respect to SIMD, there's easy ways to ensure that these don't conflict. It's a common pattern that's also used in like memcopy and stuff, or memmove. But these APIs have to assume that the data, that is the ushort contained within the span, is naturally aligned, because that's what the scalar implementation would have to do. When running on a platform like ARM32, if the data is, if the user passes in a span and it's actually like, not naturally aligned, then it will in fact, most of the APIs outside of unsafe.read unaligned and write unaligned can and will throw in that scenario. And we don't make any guarantees about working with misaligned data for basically
And we don't
any
try
API.
to check for it either.
Right, and we don't check for it either. So we would just check, are they overlapping, and if so, we do the necessary read and cache the first 16 bytes, do the operations in the correct direction, and then handle the cache bytes at the end.
Yeah,
But-
I do like that approach. Yes.
Yeah.
And just to clarify, it looks like you got all of the overloads except for the byte overloads.
Yeah, I still don't understand why we added the byte ones. I know we talked about it. I don't remember why we decided to go ahead with it, but they make no sense to me.
Yeah, so the reason that they're there is to enable source generators basically not to have to worry about the length of the numbers if you're serializing data structures over a protocol. All of that said, I don't think it makes sense to have span of byte overloads here, because I think most people would interpret that as reverse the entire span, not each element within the span.
Yeah. Instead of no op, basically.
Yeah.
It's worth noting that we should probably, right after this, review 72107. So for binary primitives, we expose Endianness APIs for most of these types, but there's a handful of ones that are missing. Like we don't actually expose ReverseEndianness for inint, inuint, int128, or uint128 today. And 72107 discusses, let's make sure we expose the inint, inuint, and int uint128 APIs as well.
So I see that we have read, single, read double, big Indian, little Indian. We don't want ReverseEndianness on there as well.
We don't have read single little Indian.
We do.
Oh, you're right. We've got the read. We don't have ReverseEndianness, and 72107 has more details on why not.
Okay.
Jan is concerned that allowing arbitrary reversal of Indianness will lead users into a pit of failure. I don't quite see eye to eye there, but it basically has to do with some CPUs may do canonicalization of signaling NANDs. And so if you allow arbitrary ReverseEndianness, then you may end up ending with a bitwise different representation throughout the operation.
Okay. So in that case, then it sounds like you're not advocating adding any overloads beyond what's listed here to the ReverseEndianness of span, correct?
Right.
So if you knew it was safe on your architecture, you could just find the equivalent size integral type and cast afterwards with that.
Right.
Like-
You'd basically treat it as float as int32 and double as int64,
Yeah.
and do all the operations.
Would we consider single span overloads of these that do the in-place thing?
I believe that was Steve's question
Oh,
earlier.
sorry. But like, did we get an answer to that? I thought I was paying attention, but maybe not.
Do you mean instead of or in addition to?
In addition to.
So, in my, I don't know, weirdness in my brain, the problem that I would have with ReverseEndianness that just takes a span is if you are doing it, I can use words, on a scalar, you have to say x equal ReverseEndianness of x. And so now you'll have a mix of lines that say x equal ReverseEndianness of x and other lines that just say ReverseEndianness of x. And just, is that going to be, you know, too much thought on the part of a code reviewer? Of like, hey, you didn't take the answer of this. It's like, yeah, well, that method behaves differently than the rest of them. The one where you take a source and a destination, it's like the call looks different. You have a 2-argument thing. So it seems less of a problem than void in place versus returning a scalar. But that's really my only objection.
Yeah, I think it's pretty minor one way or the other. I would prefer to have it, but I'm not like, obviously it's easy enough to pass the same argument twice.
I mean, do we expect anybody to ever call it with actually 2 different arguments? It sounds like we're 99% of the time we just pass in the same argument.
If you had so the place where it would be used as a with non in place would so for example, the language is adding support for that read-only span trick for non-byte primitives. So for int, uint, etc. On a big Indian system. So for example, the IBM Z computers, which we support on Mono, those will require a special runtime helpers call, which ends up doing non-in-place swapping of the data. It has to allocate different data, copy it over while swapping, and then while swapping. And so you could imagine that they use this API to simplify that implementation. There may be other scenarios where you'd want similar, where you have some static immutable data, you want to create a singleton allocation to represent the Indian swapped variant of the data. And so you'd use that API to both copy and swap at the same time, which would be more efficient than copying and then doing an in-place swap.
Can you quantify how common that is? Is this literally like a 1% case, or is it like, 40, 60, 50, 50?
I mean, it definitely is needed for such platforms like Big Indian, and you'd use it for any type of data like that. Outside of that, I don't I wouldn't be able to say exactly how common people might need it. But to Steven's point, you can do in-place copy with this API. If you only have in-place copy, you cannot do the other. And so this is the more foundational API that allows you to do more with less.
I agree. If there can only be one, I would keep this overload. I just like both.
I need to go through and count, but I included a bunch of links from some grep.app searches above, and at least a subset of them, I don't remember if it's one or half, would either need to have the two-place one or would need to copy and then do the in-place.
Okay, I was actually going to ask, how often does anybody need to do bulk Indianness transference? But if you are already talking about percentages of in place or not, then I assume that means it was non-trivial.
Whatever screen is up, I did like a 4-minute search, and you can see the links above.
Isn't networking data almost always big Indian, or is that just the packet data?
Yeah, like the IP
common.
address case that's shown there is one where it's going from a different source to a different destination. That said, it's also a small span, so we could just copy and then reverse in place. But
yeah, one interesting thing about this is your people who call this API over networking input are probably going to have to call, what is my current architecture Indianness anyway. If we wanted to be nice, we could maybe, smash these two operations together. So reverse this buffer if and only if, the architecture is not big Indian or something. I don't know. Maybe that's complicating things though.
I think that's complicating things. At least most of the examples I saw wouldn't call for that, at least not directly. Like there may have been some check higher up, but there were other things under that check as well.
Okay.
But I mean, that said, like the initial example that led me to open this issue does have such a big endian, little endian check. But that's fine.
So the nice thing about having it just take a single argument is it makes the implementation a lot easier. We don't have to check lengths, we don't have to check overlaps. Like maybe we just do that for simplicity and then say if there's a desire, then we do the two overload or the two arg instead of the one arg. Start with the simple. I know that, like Jeremy said, it's weird that some of the calls would return void and some wouldn't, but I mean, we already have this with memory extensions. Some methods return void and some don't. Granted, they are different method groups.
Right, I'm not saying we need to rename it, but if it was called ReverseEndianness in place, then you would not have a code review problem. You'd be like, reverse in place of data is like, oh, that's a bulk operation, and reverse of data that's a single operation. Is unless you're naming something with a moose or data, because yes, in American English, data is also a singular term, or X, then in general, code review should be able to read whether you're intending the bulk or the scalar operation, but there are a few cases where it gets weird.
I mean, most of our mutation operations on memory extensions, I don't think any of them say in place, sort, reverse.
No, but you also don't feel that, you could, like, data.sort, you're like, well, okay, that data must be a plural because you can't sort a single item. So it never really otherwise comes up. It's only I'm doing because you don't sort items, you sort the list. And in this case, ReverseEndianness is do the same thing to every item. And that's why it's just a minor I think it makes it harder to read. But
I would almost argue this should be copy with ReverseEndianness, and then ReverseEndianness is the in place one.
because we have an easy for this, if we needed to break a tie, it's easy. It's ReverseEndianness into, and that gives us the notion that it's writing somewhere else. But yeah, if I don't care strongly if that ReverseEndianness with a span and ReverseEndianness with a scalar are named differently. I'm just pointing out the mild concern that I have.
I think for methods where a collision is very unlikely, I think it's fine. I think it's more problematic for cases where, you know, IEnumerable exists in implicit conversions where it's now ambiguous whether you want the scalar or the collection one, right?
Yeah, I mean, we could be silly and call it ReverseEndianness.
No. There's already too many questions here. How many N's, how many S?
Yeah, just give it another E and an S.
I think if we were to come up with a different name, we would want to call it like ReverseEndianness by element or something, to clarify that this doesn't do what Levi suggested. People might think that the read-only span of byte 1 does, which would be literally just reverse the elements in the span.
Or bulk ReverseEndianness.
Oh yeah.
I think just ReverseEndianness is fine.
Indianness? I
That's what I
actually
heard.
don't mind the reverse element Indianness. No, it's kind of, I don't care.
Yeah, I guess it's a minor thing. If you're naming your variables well, it shouldn't really be too much of a conflict for a reader, but moose data, and I'm sure that there are other words that are the same in their singular and plural in English, would hit this problem.
So what's the conclusion then? We leave it as proposed, or we have a single argument one and then add the multi-argument one if we need one?
I'm leaning my vote toward the single argument one, just for ease of everything.
I'm fine with it.
Yeah, and then keep the ReverseEndianness naming. Like, I agree with Jeremy's concern, but code review hopefully will make it easy enough to recognize.
Yeah.
And like, you're expecting to reverse like the entire like span. Like that's the other interpretation, right? If it's not by element, which is just weird. Like then it's just reverse. Like I don't know. Like I guess whatever.
Yeah, that's a good point actually.
Do we have bulk? I guess the problem is we need a unary operation. Do we have bulk negate anywhere?
We have bulk for internal API names. I don't think we've ever exposed a public API name.
No, like I'm the concept. Do we have a thing that would?
We have a proposal for one.
Every element in a span. Okay, so we haven't yet cracked.
Well, we have a proposal for a bitwise one.
You mean like
one's
bulk not?
complement?
Okay.
Yeah. Well, no. There's a proposal. Levi has a proposal out for a not API.
Is
So
that
flip all the bits.
so? One's complement.
Yeah, tilde.
Yeah.
Fair enough, because it's just the same. Are we indicating in the name that it's bulk, or are we just indicating in the signature that it's bulk and that there's an expectation?
I mean, it depends on the name, right? If you literally call it one's complement and it takes, a span, I kind of would assume it does it by element. I don't know what else it would do.
Right. Again, this comes back to when you're reading a line of code that says binary primitives dot one's complement of x, and x is literally your variable name. Do you know which one you're calling? And it's like, well, are you missing the return value from this or not?
One mutates
and you
data,
can't
one
do
doesn't.
underscore equals. I don't care about the return because it's void. That would not compile.
Yeah,
so.
I guess that would be my answer. But if the wrong thing wouldn't compile, then I think I don't care. if there would be, oh, this would still compile, but it wouldn't do what you think it does, then I think I would care.
Well, that's what the reverse, like right now we have ReverseEndianness that takes a short.
Right.
If you call it and ignore the return, that's wrong. And now we would be adding ReverseEndianness that takes a span of short, and there is no return. So the two lines of the function call looks the same, but whether or not you're supposed to capture a return value depends on the type, which is not necessarily visible from the line of code.
Though I think we've reached some agreement that we're all okay with it only accepting the 2-argument proposal, right? So then it's different.
Right.
Like,
so API me prefers the 2-argument one because it's more versatile. The part of me that cares that we have deterministic behavior if the spans are overlapping but not identical, sort of like not taking the second argument. So I'm of two minds.
As long as we're deterministic when it overlaps, I don't really care what the behavior is.
Fair enough. That one, if we start at 0 and go forward, that's what we have to keep doing forever.
Yeah, we can't change between versions. So yeah. I would be willing to approve this as is. Like it's not the cleanest thing in the world, but it solves the immediate problem.
Yeah, I can do that too. I mean, like, it seems to me it is somewhat of a narrow scenario. So it's not like a mainline API, in which case the argument to have a very simple call side doesn't really apply. Like, so I think I'm good with saying you need to pass X and Y.
Yeah,
Or
and
XX.
my concern, like the more I think of it, the more I have a concern similar to but slightly different than the concern that Jeremy had, where Jeremy's concern was about like some of these return void and some of them return a value. My concern would be some of the APIs mutate their input and some of the APIs don't mutate their input. To me, that seems like more of a code failure.
do you have something that addresses that?
Having source and destination as two different parameters instead of having a single argument would address that.
I see. So basically accepting it as proposed addresses that concern.
Yeah.
And then that would be, again, something in the name that implies that it's in place, or it just tears it into two method groups. The ones that are idempotent and the ones that are not.
Right. So like I didn't quite realize that there were already methods with this name that accept the scalar version of these. That's the issue? And then return the scalar version.
That's
yeah.
The issue.
So yeah, I mean, I agree. Let's accept as proposed.
Yeah, I mean the weird thing of accepting this now, if we come back and say we want the other version, is if we decide that we wanted a different name for the, I guess if we call the in place, then there's no reason it would have collided. But if we called it like bulk, then we'd be like, well, really the source and destination one also should have been called bulk. But
we have a year to fix it.
Yeah, we'll live and learn.
Yeah. That, and I don't think it really puts callers out to have to just specify arg, arg.
Indeed.
It's not the end of the world.
Yeah.
All right, then I guess.
But paper cuts. No, I'm just kidding.
It's a real thing. I mean, I know you were tongue in cheek, but it is a real thing, right?
Yeah, but I don't think this is it. But yeah.
Yeah, this is not this is not the paper cut that's going to set someone off.
So we should also review the what was it, 7 to, oh, I don't remember the number. The other half of this I mentioned at the beginning of it.
Yeah, where we add like new int, and all that good stuff.
It just look for binary primitives and it should come up. Yep, that one. Yeah, so like I mentioned, we expose for all the other primitive types. We're just missing big Indian, little Indian, APIs for read, try read, write, try write, and then reverse Indianness. And so this is just adding them for completeness. I think we actually have a few of these as internal today, just not public.
Yeah, when you were saying we didn't have them, I'm like, but I was just in that file and saw uint 128 ReverseEndianness. But it's internal.
Yep.
Do we when we're dealing with nint and newint, do we use int pointer and uint pointer in API names still? Because it's the actual type name.
So this was an interesting case where when they were different, and so for the vector APIs in particular, we decided we should call it inint and inuint rather than int pointer and uint pointer to differentiate. We don't actually have many APIs in existence today that explicitly specify int pointer, uint pointer, inint, or inuint today. So we don't really have a convention here on which one's better moving forward. Inint and inuint might be better from the concept that it clearly specifies it's working on it like an integral type, so it doesn't confuse anyone who's been around since 1.0, but I don't have a particularly strong preference on which one we do or normalize on moving forward.
I guess my gut here would be like, why am I reversing the Indianness of a pointer? But I can reverse the Indianness of a number that happens to be pointer sized.
I mean, when you serialize your pointers, you might want to do that, right?
Fortunately, most of our new serializers don't support serializing pointers.
People will make it happen, but probably by just casting it to the equivalent numeric type.
Yeah.
Yeah.
No, I think moving forward, we probably should avoid the word in PTR for cases like that. But I think if we have existing APIs, it is what it is.
Yeah, I mean, the ones on, like, we don't have read int PTR on binary primitives, at least source.net says we don't, but we do have it on Marshall. So it's, should binary primitives match the name from Marshall or?
Well, Marshall is very specifically intended to read a pointer, though. Like that was the use case for it.
Yeah. Yeah, I think moving forward, we probably should do that, right? We should, I mean, if there's an existing type, I think you just have to live with what's named on that type. If it's a new type or a type where we haven't really taken nint or in PTR, then I think we should just decide which naming makes more sense.
So would we call it read native int? Read int native?
I think that would be the right name, right?
As opposed to nint? That's what you meant, right? Native int as opposed to nint?
Right. In particular, once we get to the unsigned version.
Actually, I think you raise a good point, because for every other type, we basically just decided that the API name is the underlying type name. So you could make an argument and say, given that nint is in PTR, that's just the API name for it, right?
I mean, it is system.intptr, and we say, we don't write read int, we say read int 32, because capital int 32 is the actual name of that type.
Yeah, given that the compiler now treats them exactly the same, I think we probably should just do that, because that's probably easier to explain to people than, well, sometimes we treat it as a pointer mostly, sometimes it's just a native sized integer. Like, that seems more prone for, naming problems.
Right. It's semantically here, you're reading a native sized integer, not reading a pointer, but I mean, it is where, Angel's dancing on the pinhead, right?
Yeah. I guess the people that use these kind of APIs, I don't think they will be confused by that.
You think so? You think, like, I kind of pray that, like, int pointer and uint pointer will just kind of fall out of favor and people won't even know that those types exist. And people will just use nint and newint everywhere.
I mean, yeah, that's the same argument for, let's say, I guess for string it's weak because it's only a case difference, right? But for everything else we have, I mean, people know that int is int32, right? So it's...
Right, and if we add a new keyword type called longer for 128, then we'd still call the method readInt 128.
And then the 256 one is longest because that's when we just retire.
No, longer.
Longer. I like it. Yeah.
Don't use a superlative because then you have no room to grow.
Well, that's what I'm saying. We're gonna retire by the time we need 512, so that's somebody else's problem.
It's yeah, exactly. So
Yeah,
I would.
So I think
if you want to use int pointer, I would grudgingly accept it, but begrudgingly being the operative word.
I think it matches our pattern for numbers to continue calling it int PTR.
Yeah, and I think the nuance difference, I think we should just not go into that. Like it's the same argument that Jared makes, that there's a difference between, string with a capital S and string with a lowercase s because the name lookup is different in the compiler. But I think for most people, it's just easier to understand that, it's a style thing. Like pick the style you want, keyboard based or whatever, right? And that will be the same here. Like for in PTR, get the same semantics whether you use the keyword name or whether you use the type name, right? So I think we can just say like, yeah, when we named the type, it was mostly meant to represent pointers, and now it depends. But, that's legacy for you. So then in terms of the APIs that Tanner's proposing here, are they, do we need to add any now for the ReverseEndianness that takes a span of those values?
I think
We just approved them.
128 wasn't in Steve's list.
It was. I'm pretty sure we just approved all of them.
We did? Oh yeah, we had the...
Yeah, it's down there.
Okay, then never mind.
Yeah, so Steve's list seems to have taken Tanner's other list into account. So
then...
now that we have generic math, we don't need all these overloads.
Yeah, there's that.
We could just say, read big endian of T, where T is I endianness reversible of T, or whatever magic interface that is.
So I propose we expose ReverseEndianness APIs as part of binary number, and that got shot down.
Oh, that's
Why?
Because some people on API review thought that it didn't make sense for arbitrary number types.
When you say some people, can you be more
bigot.
specific? Are they German or are they American?
I think I vaguely remember this now.
or
And
are they
don't
German American?
I don't remember which exactly people pushed back, but there was more than one.
I mean, just like it doesn't need to exist on the interface, but we, Levi's statement isn't facetious. We could add just binary primitives, ReverseEndianness of T, where T is a something that we can ask it to go write its bytes out.
Okay, I mean, to me, it kind of seems like, what is the value of doing that? Just because you have fewer overloads, but it seems like you're making the thing more complicated to save some overloads. Is that really easier?
I don't know that we would
It
get
means
rid of
big
the.
integer.
Yeah, I don't know that we would get rid of the specialized implementations, but yes, it would let you apply it to big integer and any other custom types.
Honestly, at that point, I would not even use in my own code the specialized implementations. I would say ReverseEndianness of nint or something, or read little endian of nint, and then just say everything is strongly typed, and I don't need to worry about the fact that I may have fat fingered the method name. I would find it clearer in the code, honestly.
You need to you would need to specify it both as the the declared type of your variable and in the generic invocation. So I would use the one that has it in the name.
It's writing that's really the problem, not reading.
Yeah.
Because I don't want writing to accidentally write too large of a number when I only intended to write 16 or 32 bits, whatever. But yes.
Oh, so write int 32, yeah, where you're giving the argument, and then you just let generic inference do it.
Yeah.
Yeah. But read is, I would call the one with the method or with it in the name.
Fair enough.
Yeah, I mean, but we didn't do that for the existing ones, right? So I mean, they're just extending what we have, right? So at this point, it seems kind of now you have the worst of both worlds, I guess.
Do VB and F# support generic math?
VB, no, and as far as I know, it's never getting it. F# is getting support. It is not in yet, and I'm not sure if it's going to be in for .NET 7.
I mean, we should be clear what we mean by this, right? So what Diva is proposing would work in VB just fine, right? Because it's just existing genericness, right? What you couldn't do in VB is you couldn't implement the method, because that's when you would need the, I can call operators on generic types kind of thing, right? Which in this case you probably also wouldn't need, because it's just dispatching to an interface method.
Yeah, that sounds right. Because I was about to ask, like, can VB even call a method that has a constraint where an interface has static implementations? But obviously it would have to, because system.int32 now does that.
Right.
Well, so
VB clearly works with int.
Well, so with int doesn't expose any APIs that are themselves taking in a constrained T. It implements the interface and it exposes members from the interface, and those are just regular non-generic, non-constrained methods. We'd have to determine separately if we exposed an API that was where T is sub of iNumber, if VB could call it. And I'd guess yes, because I would expect it's just doing a does the type implement this interface check.
Yeah.
But
yeah, I think that's what it boils down to, because it's just an existing generic constraint which VB supported since day one. So I think it really comes down to you just couldn't implement the method. You couldn't implement the generic method and benefit from the constraint, basically.
Well, I mean, I could slightly see that their version of trying to load the interface would say the interface did something I don't understand. I'm going to pretend the entire interface doesn't exist, and then now you're trying to call something based on that interface, and it's like I don't know how to do this. So
it's
not what I would expect, but I would believe it.
Which is basically what C++ CLI does, which is why we had that whole, temporary small fire drill last release with WPF figuring out, we updated int32 to implement these static abstract interfaces, and now C++ CLI won't load corelib. And we had to do the whole experimental split out while we waited for them to get their other fix in. So it's completely conceivable it does break other languages.
Yeah, thanks for reminding me. C++ CLI, I think we said it before, we just need to consider this as a thing we need to carry around. Especially when we do core type system features like this one, where we broke it entirely. Yeah, so in that vein, I think I'm in favor of what we currently have on screen, even though that's mechanically maybe not
we can...
greatest.
I think we could add the read Indianness or reverse Indianness of T with the constraint, but that our most consistent right now is to expand it for all of our built-in types.
Right.
I will say I am slightly disappointed to hear that we're willing to add it here, but we weren't willing to add it to the actual, binary integer types and stuff like that, because that would have simplified things overall for users. I'd still rather we add it in one place than neither, but it's unfortunate that we said no to the other one.
But we could still change our mind on this one, right?
And this one, because if I opposed it, I feel like one of my reasons for opposing it might have been that in 6 we weren't going to get dims yet, and it's why should everyone have to go write this when it should be expressible in terms of other methods? Now that we can add a dim on it,
proposal.
Fair enough, but like we could, if we wanted, add it as a dim on a thing that already has give me your bytes as some Indianness. I mean, I guess really it's just give me your bytes and then just swaps them. But yeah, I think what's proposed here is good, and we can talk about the other things if someone feels like proposing it.
Yeah, I mean, just as a general statement for Tenor, just because we said no at some point doesn't mean we can't approve it later, right? So if there's compelling evidence, and maybe it's just that, okay, I've lived without this feature now for a long time. It really pisses me off, and it makes my code really complicated. I think that's a compelling reason to revisit a decision alone. I don't think that just because we said no at some point shouldn't mean that you can never bring it back.
Right. It's more that this was a no that happened like 2 months ago, maybe less. And it was for, the initial version of a feature that we knew was going to be big and had a number of use cases, and where we knew it was going to be on interfaces which are, even though we have a plan for versioning them, are naturally harder to version.
Right.
So it's not the case of like I'm upset that we said no like 3 years ago and we're saying yes now. It's a little bit disappointing that we said no like 2 months ago and now we're reversing the position. Because if we had said yes 2 months ago with this consideration, then we could have, shipped it as part of 7 and had it as part of the core v10 set of the feature.
I mean, the fact that I don't recall this decision kind of makes me believe it probably wasn't super controversial. It was more like a gut feel that we all accepted at the time. At which point, like, I wouldn't read too much into it, I guess. And I mean, this is, I think, part of the problem here that most of us on the API review board have, is that we just see a lot of APIs, right? And it's just, it is virtually impossible to be self-consistent at all times. Because it very often highly depends on, what arguments were presented and what did we consider at a given point in time, right? And it's just an imperfect process. So it is possible that we made the wrong decision. I mean, it's just, that is just completely plausible. So,
Yep.
What does it mean for here? Are we okay with what we have on screen right now?
Yeah, it seemed good to me. It's consistent with the type as already is.
Works for me.
Steve, while you were gone, we had conversations about generic math. It was great.
Excellent. Sorry I missed it.
Are you though?
There may have been a slight bit of sarcasm in my voice. Not because I don't like it. I love the generic math APIs. There's a lot of them.
Yeah, that's, I think, also a problem that we suffer from. All right, so then remind me what this one is, Steven. Length count is empty.
Steve, you're muted.
Oh, sorry. Yeah, so I really thought we had this analyzer, and then I can't find it anywhere. So I think we just have several that are related, and this one never actually materialized. But there's a non-trivial amount of code you can find that does like array.any or list.any when it should really just be using, length, count, etc. And we should really just have an analyzer that says, don't use any here. It's silly.
I mean, I'm
Basically,
pretty sure I
if
got
the-
a warning like this before.
If the concrete type is known to be a thing that we special case inside the any implementation already.
Regardless of whether it's special cased in any, if the thing you're calling any on has a count or a length or an is empty, use that instead.
Fair enough. Because I know we talked about something relating count to is empty, but then found that we couldn't generalize it. But I don't think that was the same as talking about any versus is empty.
Right. I mean, there would be a discussion about if something had both count and is empty or length and is empty, what should the fixer offer to do? I don't have strong opinions, but
All of
for
them.
the analyze, maybe, sure. But for the actual analyzer, like I think, in Famous Loud's words, I think this should be extremely straightforward.
We should probably also handle larger than 0, though, right? Not just looking for an exact comparison to 0. I guess you don't have to check that at all, right? Because you only look for.
Well,
Is
this is the other.
Yeah, this is the other way. You're calling any, which returns a Boolean.
Yeah, that's
So-
fine. So we don't have to detect it. Yeah. Fair enough.
And Jose, to your question in chat, this would be info.
Yeah,
Okay.
that seems good to me.
So severity info, and then what's the category? Performance, I suppose.
Performance, yeah.
Yeah, don't turn your thing into an interface to send it into a function to turn it back into the type you were, and then write the code you should have written.
I'm just going to copy verbatim what you just said into the warning message.
Excellent.
All right. Dictionary.
Okay. This is another really small one. So dictionary has a keys collection and a values collection. These are nested public types that they're exposed from dictionary.keys and dictionary.values. The keys collection implements iCollection, but its contains method is implemented explicitly rather than implicitly, which means if you do dictionary.keys.contains, you end up getting links extension method. We have an analyzer for this that we added. I think we added it in 7. It's possible we added it in 6. But you know, even without that, we can make this a non-issue just by making that public instead of implicitly implemented instead of explicitly implemented.
Is keys collection efficient?
It just delegates to dictionary.contains key.
Okay, if I thought reading the property itself already did expensive work, and because really it's if you write if dictionary.keys.contains, you should have written if dictionary.contains key.
Right, and that's what our analyzer flags and suggests you fix. Going through keys isn't ideal. If you literally are typing dictionary.keys.contains, you're basically paying for the property access lazily initializes the extra collection object that just wraps the dictionary. So there's no benefit to that over dictionary.contains key. But if you are doing it, we might as well make it work well. Is my argument. This isn't a huge deal. We could, on for whatever reason, we could say, you know what, we really want to discourage people doing this. Just use the dictionary, and we can close this in that case. But it seems like such an easy thing to change the visibility on the member and solve the problem.
I mean, so to be clear.
Go ahead, Stefan.
Sorry. So we're not changing any of the analyzers, and IntelliSense would already contains this if you have a using link, basically. But correct. This will make it show up if you don't have link, which is arguably why it's not great if you're doing dictionary.keys.contains versus contains key.
Right. That said, I'm 99% sure that using system.link is in the automatically included global usings that we now add to every template in .NET 6 and beyond.
Yep,
good point.
Yeah, this does make system private core lib have 2 more entries in the MD table, though. I mean, that's the cost, right? Is we'll still have the thing where it says iCollection of key.contains is exactly the same as this public contains, but we have to add the public contains. Yeah. I know that this is super duper tiny nitpicky and we don't care. This is really just asking for myself if there is technically in the assembly there is a cost.
It's a fine thing. I mean, if we really think that there's zero benefit to this, then that's fine. It just seems like there's more than zero benefit. Like you do find people doing this even with our analyzer, and even with there being a better approach.
Because the analyzer is info, right?
Yes.
Yeah. So then,
I mean, I don't feel strongly about it. I just wanted to raise it because it's so simple, and I saw another code base that didn't have our analyzer writing its own analyzer for this as well.
Right.
At which point I'm like, okay, this is silly. We could just fix it.
Yeah. The only reason I asked that question is I was about to say it seems like it maybe helps someone and is literally free. And then I was like, wait, I think it actually costs 6 bytes. They're like the length of the name plus 6 bytes.
I mean, if I had to guess, my assumption is the reason they did an explicit implementation is precisely so that the code wouldn't compile and people would then go dictionary.contains key. And that was probably true until .NET Framework 3.0, until we added link and made it work, right, via the extension method. So I think at this point it's just...
That's probably accurate, yeah.
So I guess I'm in favor of what Steven is proposing. I mean, we already have the method there.
Yeah.
The MD entry seems not that bad.
Indeed. Yeah, it seems fine.
Do we have to turn off some analyzer or undo something, or because you said
no? I think we should still have the analyzer. There are APIs that are, valid to use. We still have analyzers and say, yeah, but that over there is better. I think our analyzer just moves into that category.
So the analyzer specifically checks for basically key collection .contains or something like that.
I think it literally checks for dictionary.keys.contains.
Gotcha. So it doesn't look for links.
So if you store it in a variable, oh sorry.
Yeah. So
I think if you store it I'd have to double check. I think the analyzer does not fire in that case. If it did, we should probably fix the analyzer not to, because if you actually are passing around a keys collection, you don't have the original dictionary handy to, access because it's wrapped up and it's not exposed from the collection.
Yeah, I mean, honestly though, if you actually have the variable as dictionary.key collection, if that's the actual type, then I don't think you have passed this to a method. I think at that point you're likely in the same method where you also have the dictionary, would be my guess.
Maybe.
So
don't know.
But yeah, that makes sense. All right, then I guess this is done.
Are there regarding that last issue that we were just on, are there other APIs that we should consider adding to common types, given that LINQ is now part of the global default usings?
Well,
like, is there a wider pit of failure that we need to address here, or was this just kind of a one-off?
I mean,
this was a one-off because I happened to see it and it got brought to my attention, but there may be other contains that are implicitly implemented, or explicitly implemented rather.
Okay, but this is the one that for whatever reason just bubbled up to your attention. Okay.
Yeah, this one bubbled up to my attention just because I saw someone proposing an analyzer for it in their own code base. And I was like, well, A, we have that analyzer, but B, like, this shouldn't actually be a problem. So,
I mean, to be clear, like LINQ was always in the default set of the template, so people would have to delete the using to not have it there by default. So most people wrote code with LINQ being already included in the namespace list. So I don't think that's a new problem. And I think if you look at LINQ, I think the biggest problem is probably contains, because that's reusing the thing. And then there's obviously the count method, but given that it's a method, it probably doesn't.
There are only 3 explicit implementations of this method in all of .NET.
Of contains. Okay. Yeah.
Yeah, I'm looking for what the third is. It turned up on grep and object model.
Yeah, I mean, the bigger problem with LINQ is usually that there is the conversion of the argument you're invoking it on, right? That was the whole problem with immutable collection, where, if you do, I don't know, where or, element add or something, then you would benefit from calling it not via immutable, but via the immutable array thing.
Yeah. So the third one is system object model read-only collection .key collection. So literally the same problem, and Steve just got 2 of the 3 dictionary types. So we should probably do that one too.
You get out to the third one then too. Yeah.
So which one is that?
System collections object model read-only dictionary.
Oh, read-only dictionary. Okay.
Which means now you need to use curly braces for namespace, which is why I don't like that syntax.
Jesus.
For the purposes of API I would be totally fine if it doesn't compile and you just have a separate single line at the end that is namespace. Or just omit the namespace and we know exactly what you're talking about.
I was just about to add a comment we should also cover read-only collection, but
Read-only dictionary.
sorry, read-only dictionary.
That actually raises an interesting question. I suspect our analyzer doesn't cover either sort of dictionary or read-only dictionary. We might want to confirm that and fix it. It doesn't.
Yeah, that seems fair. I assume they also define contains key. Yep, there's contains key.
We happy?
Yep. Yeah, so that is
Thanks,
literally the only 3 hits I got for iCollection of T key.contains in all of our refs.
Thanks for checking that.
Okay, so this one, we added a new library, System.io hashing, that's got a bunch of non-cryptographic hash algorithm implementations, inclusive of 2 in the XX hash family, XX hash 32 and XX hash 64, neither of which are vectorized. There is a third algorithm that is vectorizable, XXH3, which a variety of code bases at Microsoft and some external that I've seen are using, and it's a lot faster by several X because it takes advantage of SSD2, or actually I haven't seen any implementations that use ARM, but I'm assuming we can make it use Vector 128. So the proposal here is just the exact same shape as the other algorithms, just with a different name. Representing the new algorithm.
I think this makes sense. I'm looking through the docs real fast, and I know that you had mentioned SSE, but most of our inputs to these algorithms are fairly small, and this also has very good performance on smaller input, like you said in your first paragraph there.
The odd thing in this proposal, and I really, everything comes back to naming, is it's not. I'm not sure exactly what we should call it. We chose if you look at like the definition of the algorithms, they're called XXH32, XXH64, XXH3, etc. We chose to call them our existing types XX hash 32, XX hash 64. So my assumption is we want to keep that pattern going here and call this XX hash 3. It's a little weird, but if that's the naming pattern we chose, we should probably stick with it, I assume.
Yeah, I mean, the big problem is the guy or group or whatever that has this spec is inconsistent. Like they call the spec XX hash, and then they talk about the 64 or the 32 and 64-bit size. The spec doesn't mention XX hash 3 or 128, but then their performance board calls them XXH32, XXH64, XXH3, and XXH128. So the group that makes them is I think I hit this as ready for review with no discussion because I agreed with Steve's choice of XX hash over XXH.
Yes. What size would this be?
It's whatever size XXH3 is.
It supports 2 different digest lengths.
I think 3 is 64 and 128 is 128. XXH3 generates 64 or 128-bit hashes. The 128-bit variant is called XXH128. So
Should
their
that be-
XXH3 is both the family and a specific subset of the family.
should hash be returning
In other words,
long then?
Hash
No,
returns
it returns
the
the
number
number
of
of
bytes
bytes
written.
Oh, right. I'm not thinking. Destination's where it goes. Yep.
Jeremy's description does make me happy, though, that people other than us have naming problems.
Yeah, so the only real question I'd have is, should we add 128 at the same time? And I think Steve had that as a question too. And I think we can improve it. Whether or not we add it is subject to somebody caring, but the whole design of the non-cryptographic hash algorithm family is that things should basically just have this shape and we pick the name. The only question is, like XX hash is a seeded or unseeded algorithm, so it has this shape, and CRC32 is always unseeded, so it has a simpler shape. But like I think we would
Simpler
take
shape, just
it gets rid of all the seeds.
that's what I was going to ask. It's just if it gets rid of all the seeds, and if that then means it's a duplicate of an existing overload, that overload goes away.
Yeah. And then when we were proposing Marvin describes itself as only being a seeded algorithm, so its seed wasn't defaulted. And yeah, so I don't have opinions about whether or not we add 128. Chat thinks it would be a discoverability problem. I don't understand why. But yeah, I think that they did some interesting things with their naming, and I think it's actually unfortunate for this hash that they didn't write a spec the way they did for the other ones. They just said, like, you want to see how it works, look at our code.
Chad is saying that the reason 128 would be confusing is because 128 is more than 3. And so therefore it implies that 128 is newer or better when that's dependent. And I think that ultimately comes down to hashing algorithms all have terrible names, and they jump almost as badly as the Xbox naming convention has. And so, people just have to look and determine which one's the best one.
Yeah, like
We have a whiteboard in
Yeah.
building 18 covered with, if we can get around to adding SHA-3, how are we going to talk about SHA-3 256? Underscores, write out the word 3 as the word is letters. Like, hash algorithms get terrible names. In this case, we already have 32 and 64, and those are both the original algorithm family. And then 3 is really 32 take 2, no, 64 take 2, and then 128 is the new thing bigger.
We could call it XX hash 64v3.
I'm not terribly worried about people not necessarily knowing just from our API surface which one's newer, which one's older. Like, that knowledge really belongs in some type of documentation, not in our API surface. Our API surface really only has to do the job of communicating what you're actually using. But how you determine what you use is not the problem of the API.
I think for hashing, that's probably a fair statement. I think in general, we should try to give good API names so people can make a decision just looking at the API names. But it seems like for hashes, it's just, you have to decide, how you want to screw yourself, right? Because there doesn't seem to be a naming convention that would work for everything.
Oh yeah, for algorithms specifically, like it's incumbent on you, the developer, to know through some other mechanism what algorithm is appropriate for your use case.
Right.
But our API should clearly say this is the algorithm that you're getting if you call this API.
Right.
Right. And the XX hash entity calls this one XXH3. And again, with our previous XXH32, we called XX hash 32 because that's what they call it in the spec instead of the table. I think XX hash 3 is the right name.
Cool. So I wrote this up because I think that's where we landed, but is that actually a fair statement?
That looks right to me.
Okay. Then I guess that's where we are.
Steve, did you say that we had folks internally already asking for this?
Yes.
Okay, cool.
I can talk to you offline.
Okay, thanks. Oh man, this is going to be fun.
So we've had some requests for being able to validate that data is base64 data without actually requiring the space to decode it into, or even doing the decoding, which adds a little bit of overhead. Basically, you've got some data coming in from a config file, and you want to validate it, but you don't actually need it. You want to promptly validate it so that you give people good errors, like when their app or service is starting up. But you don't actually need the decoded data maybe ever, or you don't need it till later. So you just want a fast validation call. So the proposal here is just a simple is valid on the existing base64 class, one for bytes, one for chars, saying whether it is valid base64 or not. Just a very simple yes or no.
So I have a clarifying question on this.
Yeah.
When you say is valid, does that mean it is actually honest to God valid base64 or convert dot from base64 string can understand it? Because there are two different questions with two different answers.
Explain the difference to me.
Convert dot from base64 string understands certain payloads that are not valid base64. It will try to fix them up and then return an answer to you.
I could not have told you that. What's an example of something that's wrong that it will fix?
This actually came up on Twitter the other day, and I know that we spoke about this a few years back too. But I think the payload AB == will be decoded with air quotes around decoded by convert dot from base64 string, even though it's technically invalid base64. It should be AA == because there's leftover data after the end of the buffer, and according to the base64 spec, that is something you're not supposed to have.
That happens a lot, though, right?
It does. Common. That's why I'm wondering what is valid is supposed to do in this case.
Right. I would say that's probably valid if our tools accept it. If
tools accept it, but Python, I don't think Python will accept it. Go will not accept it. Rust will not.
Oh
accept
goodness. It. Okay, never mind.
I mean, I think assuming that we in our convert from base64 and our base64.decode from UTF-8, etc., if they're all going to accept, let's just call it non-canonical termination, then I think our is valid is the precondition of is it going to throw, and that's all that it should answer. If we have a different
I think they should be
implementation between the UTF-8 one and the UTF-16 one, then that's a different problem.
Do we accept different? I mean, we just. Yeah, I don't know the answer. Levi, do we accept the same things across the board, just one with bytes and one with chars?
I don't know, honestly. That would be a good test to run.
Because, yeah, I don't remember seeing something in a base64 spec, or at least not in the original PIM spec that defined it. I don't recall it saying that specifying, AZ equal would be invalid, even though it meant that you assigned some don't care bits. I personally don't recall that.
Yeah.
No encoder should ever produce it because it's nonsense, but that's one of those cases where because you said equal, that says ignore this many bits off the end. And
yeah. So anyway, if it looks like we have a few different places we can go with this. If we want this just to be a precondition check of, would this method have thrown an exception or not, then that's, that can be the definition that we use. We just want to make sure that there's consistency between the char and the byte overloads, right?
Yeah, that would be my inclination. If they're the same, we should just have it be entirely consistent. If they're different, we're going to have another conversation.
Right, because like the PIM encoding class wrote this functionality because it's in scanning of finding is something legal PIM, it needs to know if something's legal base 64, and all it checked was the character size came out as mod 4, ignoring white space, and that all the characters were within the valid set. But it doesn't check that you assigned don't care bits. Yeah, so because we've written this in PIM encoding, I'll say that what PIM encoding actually, its version is try count base 64 instead of just is valid, because it wants to know when it stopped. Because basically it's saying when it stopped, if we now see some dashes, then we're ending a PIM encoding block. But
so it would be nice if we could, use whatever we add here in any place that's relevant. If there's a different variation of this that wouldn't add measurable expense, that would be useful in even more places. I'm happy to see that. It would. I mean, if we did this as a try count instead, or an addition, and is valid implemented in terms of it, was not particularly more expensive.
Yeah, I mean, so it looks like the only thing it's actually checking, just trying to read where it is in code, is it's using it for so it found the start hyphens, it found the end hyphens, and now it's everything in the middle has to be base 64 and or white space. And so it's like, well, since I had to look at the characters, I can tell you how much leading and trailing white space I had. And it also reports, because of the number of characters it counted that weren't white space, it can tell you how big the output's going to be. And so it does answer a second question into is valid. That's not just trim, which is cool. How big of a size do I need to decode this? Assuming that our base 64 class and convert from base 64 both ignore white space, which I'm pretty sure they do. So there would be room for is valid and is valid out count, and then if we cared is valid out count without leading white space and out trailing white space. I don't know how many of those we want to do, but that's the current place that I know that we're asking the is valid question. We're asking those extra 3 pieces of information.
You're suggesting you trim white space from the input, or in the middle as well? Is it just the when you're doing PEM?
When you do the PIM encoding thing, it gives back a range that tells you here's where the base 64 content was, and that's the first entity in the range and the last entity in the range are not white space. So it's trimmed out the white space from the range, and it did that as part of asking was the base 64 valid. It could still do that work later by just skipping white space on the theoretical range. But
so if they're if I'm reading this from your file and there are new lines in it, is this ignoring that?
New lines and space and tab and stuff are all legal inside a base 64 payload and they don't violate your buffer.
Right. So I'm not expected to do any of white space trimming up front.
Right. It's just for some reason when Martin wrote the base 64 thing, he was like, yeah, let's just trim off the white space in the front in the end because we're already doing the work. We could certainly we could soften our implementation and say that it now returns some white space, or we could trim it manually in terms of a thing here. But one piece of data that we would need to maintain is counting how many semantic base 64 characters there were to know how big the output buffer would be. So I think that is a piece of data that is useful in addition to just the Boolean.
Is that more work to compute that?
I mean, basically,
Probably not.
the implementation for is valid, assuming it's going to check that you didn't leave off trailing equals needs to count. Did I get a mod 4 number? And then all it does is return the 3/4 of that number answer. If it's only checking did you use only base 64 legal characters and isn't checking that you didn't call base 64 decode on just the string A, then that would be different. But if it's doing a length validation, then it has the answer. Modulo multiply and divide, which is really a multiply and a shift.
Off the top of your head, do you know what white space is like valid or will be skipped by this?
Space.
If you don't, that's fine.
Space, horizontal tab, new line, and carriage return. And that has a comment here of these are the white space characters that convert dot from base 64 ignores.
So it doesn't check the Unicode
Not off the top of
category?
my head, but the code was on my screen. So yeah, it's not the whole Unicode is white space. It's just those 4. Basically, the is ASCII white space and ignoring vertical tab because no one knows what that means.
I mean, as an invariant, I think the only thing we really care about is that is valid can't return true and then decode would throw, right? But we could have a mode where is valid is returning false while encode would still give you a valid response, right? It would be less useful, but it would be okay, I guess.
Yeah, it would be okay as long as we also need the invariant that it returns true for anything our encoders would output.
Yeah.
Right. But I mean, the primary value of this API is performance, right? So if we do something super expensive, then that also defeats the purpose, right? At that point, it's just call the method,
Correct.
right?
But yeah, like if we think there's value in people just having the answer as a Boolean, then my only real suggestion would be add an overload on these that each outs the I think we called it decoded count, but decoded size. So if you want the answer, you can get it from the out, and if you don't, then you don't have to do out underscore. White space trimming, I'll
So it would be out int decoded length.
Yeah, unless one of length, size, or count. I don't know if we actually have a standard here.
I mean, I think length makes more sense, given that. What is the thing called on span? Is it called length or? I think it's length, not.
It's
count,
length
right?
on span.
Yeah, then I think length makes more sense. I mean, I'm okay with that. I mean, I would still have the overload that only takes one argument, though, because I think discards are ugly. But
Yeah, that's what I said. Add an overload instead of change the signature.
right. We cool then with that? Maybe I should reorder them, but it doesn't really matter probably.
It seems good.
Jeremy, other than any kind of issues with that standard targeting or the like, could PEM's encodings use be replaced by this?
So PIM encoding's use could be replaced by this, and then if we care about making sure that the current status, that the range it says where the base 64 data is starts and ends with a base 64 character, then we could just trim white space ourselves. But we could get rid of the long loop of counting and incrementing.
Great.
And it's in system security cryptography, so it's inbox.
So no net standard issues. Yeah. I mean, with any of these kinds of helpers, one of the goals is to eliminate any bespoke implementations we have. So hopefully that can be replaced.
Right, and that's why, having seen it, I jumped to like, hey, we have this in crypto. We needed to know the answer to the question. Is this valid?
Excellent.
And I'm pretty sure we have unit tests that say exactly what ranges we expected to get back. So that'll tell somebody if they wrote trim start and trim end correctly. And in fact, I think we have that as easy now, right? Like we just make the span of what characters we want to trim off the beginning and end, and we have the first index of not these.
We certainly have the first index of not these. I don't know if we have a trim for that, but layering trim on top of that is easy.
Right. I mean, first index of not, because we're returning range, not a string. So first index of not these would just be, we say the range start is first index of not these, and the range end is last index of not these. So. Cool. Ship it.
Yay. All right, so I think that's it for today. We are 10 minutes over. We got all but one issue reviewed. That's pretty good. Then
thank you, everyone.
I see you guys next week, I guess. Sounds good? Yeah. Bye-bye.